Hello BC Calculus students, this is Mr. Johnson, and this is section 1.7 on parametrics. This is the calculator supplement to the lesson, and I'm just going to go through a few examples from the notes that I went through in the video. So if you want to take out the examples so that you can follow along, all I'm going to show you on this particular screen are the calculator operations and how to do the parametric mode and parametric operations on your calculator themselves. So first off, if you go to your mode and down a few steps here, usually you're in function mode, but you can move over to parametric mode and hit enter. And the first thing you're going to see is in the y equals, you'll have now x and y, and they're functions of t. So when you click the button that you normally do for x, now it's going to be a t, because now you've changed into that particular mode. So let's do, for instance, the very first example in the notes on page 16, where x is t squared and y is t plus 2. We graphed this one by hand, but now what we're going to do is attempt to kind of see the same thing on the calculator. So go to your window, and the t minimum, if you remember from the problem, was -3, and the maximum was 3. And the t-step, I'm going to explain this in a moment. So let's put the t-step at 0.1, okay? The x minimum value, the x values were from 0 to 9. So let's make the x minimum -1. I just did -2, sorry. Let's do -1. And then the maximum, let's make that 10. And the scale can certainly be 1 there. And then for y, if you remember, the minimum was -1, so let's do -2. And the max was 5, so let's do 6. The scale can be 1 there. Let's go ahead and graph it and see what happens. So again, it graphed it pretty quickly. This is certainly the same type of graph that we saw, which is good news. We didn't quite see the motion, at least I didn't on my screen, where it sort of graphed it for us. One thing we can do is let's go to the window, and if you go down to the step, change the step to maybe 0.6. So I'm actually increasing it here for a moment. And if you graph it, you can start to see that it's a little bit boxy. If you go to your window and change it to, let's say, 1 and make it even larger and graph it, you can start to see that it actually starts to straighten out a little bit there. If you made the step 3, my guess is that it's going to look like a triangle like that. Now what's happening? Well, the t-step is really important because it allows you to graph multiple pieces of data along that curve. So you don't want to do a t-step of 0.000001 because you'd be there all day waiting for it. But maybe 0.01 we could try, and you can see at least it slow down, and it's a nice smooth curve here. I'm going to show you one other thing that helps you with parametrics. If you go back to y equals and you go over to the left side where the color is and hit enter, you can change your color, but you can also change your line. And if you press over to the right, there's a little dash with a circle. And what that does is it draws the graph, but it also shows what kind of looks like a particle moving along the graph. So it allows you to see it really clearly what the actual path of the particle is. And I think this is super helpful because now you can, figure out, for instance, in example 3, when we start to get some sort of graph where the particle is sort of backtracking along the same path, that operation of the calculator will help you greatly when you're tracking that behavior. Okay? All right, let's move on then to example 3. I'm going to skip example 2. You can certainly try example 2 on your own, but I want to show you with example 3 how helpful the calculator is in seeing some of this stuff. So x is cosine of 2t and y was sine of 2t. And if you remember, our t value was from 0 to 2 pi. And then we know the circle has a radius of 1. So let's just make x -2 to 2, and we'll do the same thing for y. Okay, what I'm going to do here, you don't have to, but I just want to show you how misleading it can be. I'm going to change this back to sort of the standard graph. And there's our circle. Boy, that was really quick. Whoops. So let's do a t-step. I changed it back. Let's do 0.05 maybe. Okay, so here's our graph. Oh, it was still quick. And if you notice, it doesn't at all show you that it's backtracking through that graph. So I'm going to slow it down even more. You can see the path, but it definitely does not appear as though it goes around twice. So if you go back and change that setting, so you have that little dash and the circle there, that will help a lot, because now when you graph it, you can see that the particle is moving in the pattern that we had determined in example 3 when we were studying it. But watch what it does. It starts to go again, because remember that period for t was 0 to 2 pi, and the trig functions had a 2t on the inside, which ended up increasing the number of periods in that domain. So anyway, I think that's very, very helpful. You can certainly go back and try any other examples here. I think real quickly I'm going to show you example 3, the one where we have the parabola, just to show you one last one. And then I'll let you go and you can try some of these on your own. One thing to keep in mind for this one is that we're squaring sines, so you want to make sure that you put sine of t and the whole thing is in parentheses squared like that. That's helpful. In terms of our window, let's go ahead and do x from -2 to 2, and then y can be, maybe let's just do -1 to 2, something like that. Okay, so here we go. So we have, remember, it starts at 0, 0, it goes up to 1, 1, then it comes back down, and it goes down to 0, 0, and then it goes over to -1, 1, and then it comes back down. So you can really, the calculator can really show you the path of that particular particle. And if you want to, kind of go into a daze, you could change the t value here from 0 to like 100, and you would just see this little ball go back and forth, and you'd start to get hypnotized. Okay, hope that's helpful. Thanks, and have a great day.